This presentation covers a rebuild project of an Ingersoll spindle unit at Manufacturing Maintenance Solutions, MMS. This project delivered highest quality rebuild and repair results at competitive cost. The spindle unit arrived at MMS after being removed from service and was still quite dirty. Evidence pointed to this spindle having experienced more than one crashes, from broken or missing hardware to gouges and surfaces. Following cleaning, more detailed initial inspections were made. Seen here, broken, loose, and missing hardware is noted. For a unit that is running at arrival, more data can be collected. These include things like vibration, temperature profile, clamping force, spindle runout, and others. Inspection and fault analysis continue throughout teardown and disassembly. Here we see coolant intrusion exacerbated by missing fittings. Each component is carefully inspected and documented. Damage is noted. All shafts, bores, and journals are polished for proper fit where rust or contamination are found. All components are cleaned thoroughly, even the ones that will be replaced. Critical dimensions that affect bearing preload and gear performance are measured and verified, both as found and for new components. Where necessary, bearing spacers, shaft or housing spacers required to achieve proper fit are modified or made new. New bearings are then precision cleaned, lubricated to calculated fill volume, and installed. When the subassembly is complete, the unit is assembled to tri-fit. The gears are timed to one another and backlash established. The gear mesh of the bevel gear set is of critical importance, so it's checked using the transfer rub method. Unacceptable fit is corrected by changing spacers. A common practice for many machine tool builders is to even the appearance of as-cast surfaces with a body filler before paint. The exterior finish of this unit had finally deteriorated to the point where it was necessary to take the surface all the way to bare metal and renew the body fill. The unit was then prepped for paint after assembly. High durability primer and 2-part resin paint were applied. After paint, the unit was returned to the spindle room to be run in. For this type of spindle unit, the run-in process is nearly 6 hours. During the run-in, vibration data is collected, and just after, other spindle data is collected, such as knockout, clamp force, spindle face compliance, and sensor settings. The spindle tool taper is checked. Spindle runout is measured and taper contact is inspected with a taper contact tool. When required, the customer may request MMS to grind the spindle tool taper to restore original fit and finish. MMS also offers storage of offline spindles. All spindles will be stored in a climate-controlled facility. All spindles will be prepped with rust inhibitor and wrapped in VCI paper and water-resistant plastic wrap. All spindles will also be stored on a layer of closed-cell vibration dampening foam to reduce the chances of ranelling. All grease-lubricated spindles will be exercised every 90 days, and all oil-lubricated spindles will be exercised every 30 days. All spindles will have a full run-in and vibration analysis performed after every year on the shelf. This video shows the spindle unit during the run-in process. Thank you for watching this presentation on the rebuild project of an Ingersoll spindle unit at MMS.